It's Tuesday, the 20th of June, and time for an Oroville update in the mighty Luscombe. And the news this week is the heat. It's been over 100 degrees every day for several days now for the highs of the day, and it looks like it's going to remain that way for a few more days. So let's see how that affects operations down there in Oroville and how the boys are doing on the reconstruction. We got a DWR conference call coming tomorrow, Wednesday. We'll check in with them, see how the heat's affecting them, and more importantly, get to all the questions that we've had coming up to this point and all of your questions as well. My name's Juan Brown, and you're watching the Blanco Lirio channel.
The children well, the father's house will slowly go.
What'd you get? You broke your pole. What do you got? Is it there still? Oh my God, he's still on there. Yeah, you got the whopper, Julianne. You got it. Let go, peek it back. Don't worry about that. You got the big one, Julianne. Oh my gosh, look at this. You got him. You got him.
After a great Father's Day weekend with the kids, it's time to head back Oroville and see what's going on. The lake level at 812 feet looks like they're keeping it right at 812 feet, which is a good compromise. That gets the water level just below the bottom of the spillway gates and allows maximum storage for customers downstream without interfering with the project. Inflows are matching outflows about 4,500 CFS via the high-up power plant. Because of the extreme heat reaching 115 degrees Fahrenheit on the surface of the spillway, crews are working 2 10-hour shifts, avoiding the 2 to 6 p.m. portion of the day. A little more activity here at the structural concrete plant on top of the boat ramp. Again, this is the plant that's going to make the concrete for the actual spillway on top of the roller compacted concrete. And the extreme heat affects concrete operations, but crews are able to compensate, controlling the temperature of the concrete with water, ice, or blankets or other techniques. This plant will become operational next week and is expected to produce 146,000 cubic yards of structural concrete. Just as we suspected from the last update, we're beginning to see the creation of the Secant cutoff wall below the boat ramp on the emergency spillway. This cutoff wall is expected to be 1,450 feet long and located approximately 700 feet downstream from the emergency spillway. The footings are going to go down 30 to 50 feet to solid bedrock, and it'll be relatively flush on the surface. And the whole idea, of course, is to prevent erosion from getting anywhere near the emergency spillway if it's ever used again. This Secant wall will be extended across the face of the emergency spillway, and everything between the Secant wall and the OG weir will be filled with roller compacted concrete. They'll pull out the existing repair job and replace it with new roller compacted concrete. See the previous update for more details on Secant wall construction. The power lines that you see in this view will be removed and rerouted away from the emergency spillway. So Jeff said at today's DWR Media conference call, they've got 420 pieces of equipment on the site right now, 58 to 62 million bucks worth of equipment working right now. 425 folks are currently employed, and they're going to peak out at 500 folks total. And right now they're working 6 days straight, 10-hour shifts. Here's some of the questions and answers I got at today's media conference.
Then take your questions, which will be managed by the call operator. First up, if you would like to ask a question today, you may do so by pressing star 1 on your telephone keypad. If you are using your speakerphone, please release the mute function. Once again, that is star 1 to ask a question. And your first question will come from Quan Brown with the Union Grass Valley, California.
Hey, this question's for Jeff. How does the spillway design for this year differ from next year in order to handle more flow next year? Is it just simply the height of the walls?
Yeah, Jeff, actually, this is Aaron. Juan. I can take that.
Okay.
That's one of the aspects. It's also just about, completing the project as a whole. As you know, the upper portion of the spillway won't be reconstructed this year, and it'll be finished next year. So there are a couple of, reasons there are a couple of different reasons as to why we're not going to be able to put down the full 270,000 CFS this year. One is the height of the walls. One is also the finishing of the concrete on the main spillway, if it's going to be RCC or if it's going to have that structural concrete on top. I don't know if Jeannie or Jeff, you want to expand on that anymore. No, I think you covered it.
And does it just spill over the sides if it exceeds? Does it just spill over the sides, or is there like an outlet for the canyon?
So that's part of our contingency plans. Obviously, they're still figuring out exactly how it's going to be designed and constructed, but the idea would be to have an opportunity to offshoot any excess water if we needed to use it at a rate of higher than 100,000 CFS to then push water over the spillway wall, essentially, and into the canyon.
Okay, great. And as the left side of the spillway coming down the spillway is blown out by the canyon, is it the nature of roller compacted concrete, the way it's layered on like a stair-step fashion? Does that mitigate the need for a large retaining wall design on that left side of the spillway?
I believe that the design does have retaining walls on both sides, regardless.
Oh, okay. All right, great. And then when you get to the rebar that we're seeing on site now, is that all getting prepared for the structural portion of the spillway, or is there some rebar going in the RCC portion?
There's no reinforcement in the RCC. It's all for the structural, and it could be. It likely is being prepared for all the structural concrete. That's my assumption.
Okay, and then once you guys cut me off when I get too long, too windy here. But how do you physically connect the structural portion of the spillway to the roller compacted concrete base of the spillway?
Jeff, do you want to jump in on that one?
Sure. There's what we call slab anchors that are installed into both the rock and the RCC foundation that come up into the structural concrete slabs.
Great. And is there going to be big keyways and footings in between the expansion sections this time around?
So I'm not sure how much detail I'm allowed to talk about.
Sure.
In the exact construction, but yeah, there are footings, substantial footings underneath the walls, and improved construction joints within the slabs to keep everything anchored together.
And
Juan, I'm gonna.
Okay, go ahead. Yeah, I'll jump in later.
Where we're gonna cut back to the other questions, and you and I can follow up offline and maybe get a full list of all the questions that you need.
Okay.
Great. Well, sorry, cut you off.
We did have a follow-up from Quan Brown with the Union Grass Valley.
Hey, Juan.
Hey, on the last BOC report, there was some debate on the drainage, how to finish off the drainage, whether they were going to go with the open ditch design along the side of the spillway or enclosed piping. Do you know, have they settled that debate yet, or are they still working on it?
I believe they're still working on it, but I will get back to you if otherwise.
Okay, very good. Thanks.
presentation. We do thank everyone for your participation.
115 degrees in the spillway. Yikes, that's hot. Miserable working conditions. Hats off to the hardworking crews that are doing this dangerous, tough work. So down here at the bottom of the spillway is the RCC batch plant, the roller compacted concrete batch plant, which is in production now as of June 17th. This plant is expected to produce 800,000 cubic yards of concrete, or about 227 Olympic swimming pools worth. On this side of the spillway is the prefabbed rebar sections that are going to be used in the structural concrete portion of the spillway. And the plan right now is for 8.5 million pounds of structural rebar to be dropped into this design. Some blasting and excavation work is still going on, as is dental work and test fills. And the laying down of RCC should begin in earnest now, right after the 4th of July. Dust mitigation measures have been ongoing, and little to no asbestos dust has been detected on the site. So stay tuned for further updates as this thing starts to shape up. I'll provide links to the live cams, up to 4 live cams now, and DWR is promising us a time-lapse video of this entire project. That'll be fascinating to watch. By viewer request, some of you have been asking about the effect of heat on aviation operations, and so we'll talk about that next as soon as I land.
Now that we're done flying for the day by 9:30 a.m., you want to get your flying done early during the summer in these light airplanes because of the effect of density, altitude, and heat. Viewer Stan Rooker and a few others were asking about the reports in the mainstream media about the airliners. How come the airliners can't fly in this heat down in Phoenix especially? Well, it's not so much a matter that they can't fly in the heat. They don't understand the difference between can and may. Yes, they could fly or they can fly, but may they fly? No. And I'll explain more about that in a minute. Small airplanes like the mighty Luscombe here, heat has a tremendous impact because these aircraft are relatively underpowered to begin with. Right now at 9:30, it's 31 degrees Celsius, approaching 90 degrees Fahrenheit. The field elevation here is 3,200 feet, but the density altitude is 5,600 feet. A tremendous performance difference. Why is that? Well, as air heats up, it expands. As it expands, there's less molecules. The air is literally thinner. Less air for the wings to lift and less air for the engine to breathe. So the engine is producing quite a bit less horsepower on a naturally aspirated engine on a hot day. So you'll read about aircraft accidents every summer on departure typically, unable to make obstacle clearance and packing it into the trees in the mountains during the summer. Naturally aspirated, of course, means it's not turbocharged.
Here's a famous YouTube video of an old Stinson Voyager overloaded, too many people, too much fuel, on too hot of a day up in Idaho. Many minutes later after takeoff, still struggling to climb out of there, impacts the trees. Everybody survives this crash.
Unlike these small airplanes, every single airliner aircraft is certified to operate at a variety of temperatures because it's been tested and proven to operate safely at these different temperatures. But at some point, the data runs out. The operators haven't tested it above these temperatures, or they haven't got enough data points above a certain temperature, and so they simply don't have the data. If you don't have the data, you cannot take off. You may not take off. You could take off, but you may not take off. Why? Because if something goes wrong, the lawyers got you. You don't have the data to prove that your takeoff was a safe takeoff. Each and every single takeoff in an airliner is measured to the nth degree, and here's what some of that data looks like. And here's an example of some of that takeoff data for an airliner. The temperature, the planned takeoff weight, assumed takeoff weight, zero fuel weight, the fuel load, engine pressure ratio, EPR, takeoff CG, stabilizer trim, all this data is figured out to the nth degree for each and every single takeoff on each runway and each runway intersection, plus the wind is taken into account. A whole mountain of data goes into every single takeoff for every single airliner. And all that data takes into consideration a whole number of factors, not only just for a normal takeoff, but for almost every conceivable emergency that can happen on that takeoff, that you still have the appropriate performance margins as required by the FAA to safely clear all the obstacles.
All the considerations that go into each and every airliner departure is enough material for a whole nother video or short video series, which I might get into the future. A fascinating subject. Your support of this channel and on PayPal, we're able to keep this fuel bill paid. Thanks. 10 gallons, $42.50.
Will, and we were just talking about the same idea of doing infographics. I think, Jeff, did you say that this amount of concrete would fill an Olympic-sized swimming pool or build a sidewalk to Hawaii? Which I would love. Just saying. Jeff, are you still on the line?
Yeah, sorry. The RCC quantity would fill 227 Olympic swimming pools.
Oh, 227. Oh, okay. That's a little